Okay, so one more thing that I thought of that we should do before we try to graph it is think about local mins and maxes. So we know that it changes from negative to positive, like decreasing to increasing. So like that. So I think there's, and I know there's a local min at the fifth root of negative 1/4. So min at the fifth root of negative 1/4. That was my only critical point. So one other thing in addition to that that I wish I had thought of before is I actually know that there's a vertical asymptote. This is something from pre-calculus or like an algebra class that you would have known. But my original function t to the fourth minus 1 over t, since it has division by 0, that tells me that there's going to be a vertical asymptote at t equals 0. It's actually quite a bit of information that we could graph in there. So at 0, there's some kind of vertical asymptote. It's a really terrible way to draw that, but I'm attempting. And then I think we found an x-intercept. Let's see. Oh, and actually I realized that I made a mistake with the x-intercept. So let's see. When I found that t equals 1, that would mean 1, 0, not 0, 1. So the x-intercept is really 1, 0. So I could graph that. Put 1, 0 here. It's got an x-intercept. And then I know there's a minimum at the fifth root of negative 1/4, which I'll just put right there. So something like that. And then I'll connect it up with my vertical asymptote to look like that. Something like that. Because I need it to be decreasing from left to right. So that gives me this guy. And then increasing towards 0. And then from 0 to 1, which is where my x-intercept is, it is increasing. Yeah, yep. So we'll go like that. And now I'll check on concavity. So it's concave up from negative infinity to 0, and that checks out with the picture I've got. And then concave down from 0 to root 5 of 1/6. Okay, so now we got to be careful here. So the fifth root of 1/6 is, we're going to say like right in here. So I want it to be concave down until then. And then it's concave up afterwards. So something like that. Okay, so here's the scary part, is now we need to check it on Desmos to see if I got this right. So I'll pause here and we'll see what Desmos thinks.